So now we're going to assemble the valve for the active dual ventilation system. So we're going to start off by putting the O-rings on. So first of all, we'll pop one on the sleeve part. It's pretty straightforward. It just sits in the groove at the bottom, and you don't have to worry about it too much because it's pulled upwards into the inner part of the valve later on. The outer part, sorry, later on. The next two are the more two fiddly ones. So on the inner part of the valve, these two O-rings, I think they are approximately 22 by 2 millimeter O-rings, and they have to sit in these grooves here. The easiest way to put these in is to start off them on, just push them into the groove on 2 or 3 sides, just making sure that you don't have a buildup of excess slack anywhere, and then using the pie part, the wedge that is actually the valve, just push that in quite firmly, and that should seat it quite well. It should be quite resistant to coming out when it's properly in, and it might take a couple of goes to seat that fully. And the same on the other side. This one is quite size dependent, so if you're, for example, using an imperial size O-ring, this might not work. You might have to actually source the metric O-ring, 22 by 2. You should be able to, if you look straight down flush with the sealing surface, so flush with this surface just in here, they should protrude slightly above that surface, but not by too much, and they should protrude uniformly around the entire O-ring. So if they're not seated properly, then just give it a couple more goes, and it should get in there quite well. Cool. And then the one on the axle, so we need this a small little, I think it's 6 by 2 over the shaft, and this one is probably easier with a tool. So if you start off one side and then using some sort of screwdriver or Allen key type thing to stretch it over the rest is the easiest way. Here on hand. You do want to be mindful though that if you're using a sharp tool that you don't damage the O-ring itself, obviously, because that is bad. I'm struggling today. There we go. And that sits in that groove, just like that. So again, it sticks out slightly further than the rest of the shaft. Cool. So now we'll get the sleeve part and we'll insert that into the outer part. So there's a hexagonal key here that sits into a hexagonal key on the inside of the outer part. So that aligns and it should push up. It should be a relatively tight alignment. On this one I've made a couple of modifications just by cutting the 3D printed parts, but I have updated the designs, and so you should not have to do that. So that pushes up. And then you take the nut and thread that on. It should thread easily. We've got very loose tolerances because it doesn't actually have to seal on that, and you should be able to crank that quite tightly. I haven't managed to break it yet, so if you do, let me know and we'll make it stronger, or we'll tell you not to tighten it so tightly. The next part is the pie. This gets inserted in. The easiest way for me is, so this small cylindrical protrusion at the bottom gets caught in the extrusion at the bottom of the outer part. So the easiest way I found to do this is to insert it so that it is directly down, and then while pushing directly down is to get the shaft, and the small 6-pointed star goes in, not the large 8-pointed star goes in. And you should be able to, with a little bit of wobbling, push it in, and there you can see that that's bounded fully. So now, if you rotate the pie, the shaft on top rotates. Oh, the final other O-ring that I forgot at the start is to just put the large O-ring on around the outside. the size of this one doesn't really matter as long as it's actually stretched over the entirety of the inner part. And then the notch goes around that cylindrical extrusion of the pie, and they should simply push together. It's often easier to get one end in and then twist the other end in. And if you have difficulties here, a couple of things can be happening. One thing is that because this surface here should be on the print bed when it's printed, and so therefore there might be a small rim around here, which if you just trim that with a sharp knife or sandpaper or something, that should help it. And then you should just be able to push the two together like that. And there you go. That's most of the valve assembled. There's just a couple of bolts that hold it together. One through there and one through here. It may be easier to put the servo motor in before you do this stage, but I prefer to do it first. And it's not necessary to use nylock washers on these joints because you can get quite a lot of tension on, so I just use a standard 3mm washer and then just a basic 3mm lock washer, split washer, although that's probably not necessary because you can put quite a lot of tension on these fasteners. Then standard non-nylock nut. You shouldn't have to tighten this too much. On some of the earlier designs, the inner part does push against the outer part, which means that it's actually hard to compress the O-ring sufficiently. But on the current designs, you shouldn't have to tighten it too much. That said, I also haven't managed to actually